We are back with another video lesson. There will be opportunities for you to engage with this lesson throughout the video. So remember, if you have any questions about this, please reach out to me. So this first part of sections 9.1 and 9.2 is going to focus on section 9.1. And section 9.1 is all about solving linear equations in two types. The first type, just some variable plus a number equals a number. And the second type is going to be a number times a variable equals a number. Okay? So any linear equation in X can be written as X plus B is equal to C. Okay. And let me make sure that I don't confuse you all with this. Okay. I'm sorry. Yeah, so it's actually written in the form A times X. We're going to get into that in 9.2, but this is the general form of a linear equation. And this is where A is not equal to 0. Okay. Now, the addition principle of equality. What this is saying is if we have some number A and some number B, and they happen to be equal, then we can add the same thing to both sides and not change the equality of what we started with. Okay, so continue, because consider if we have like 4 equals 4, okay, well, the only way that we keep that the same, if we have 4 plus something equals 4 plus something. The only way we keep that the same is if that something is the same number. So, like, let's just say 9. Okay? So that's the addition principle of equality. And the multiplication and division principle of equality tells us that if we have something that's equal, A and B are equal, then we can take these and multiply them by the same number. So again, consider, we've got 6 equals 6, right? Well, if then we have 6 times something equals 6 times something. Whatever we have there, any number, it has to be the same. Okay? So let's talk about the procedure for solving linear equations in the form of x plus b equals c. Okay? So the first thing that we want to do is combine like terms on both sides. And then add the opposite of b to both sides. And then you can check your answer by, if you want to, by plugging in. Okay? All right. So let's take a look at our first example here. First example, x minus 3 equals 7. So the first thing that we want to do is write our equation. X minus 3 equals 7. Okay? And remember, this is in the form x plus b equals c, right? So remember that our first step is to combine like terms on both sides. Well, that's already done. We really don't need to do anything there. And then the second step is to add the opposite of b to both sides. So in this case, we are going to add positive 3 because our b is this minus 3. So the opposite of minus 3, plus 3. Okay? So what that gives us then is these two things cancel out. And we're just left with x equals 7. That's our simplify step. Okay? And then we can check. Oh, I am so sorry, y'all. I was looking at the 7. X equals 10. I'm just making a lot of mistakes on this. And then to check, we can substitute 10 back in the original equation. Okay? So come back to our original equation here and say, well, 10 minus 3 equals 7. Well, 10 minus 3 is 7. And yes, 7 does equal 7. Okay? It's not always necessary for you to check your answer. It is helpful sometimes. Okay? All right. So this one, we have negative 11 equals y plus 5. Okay? So this is kind of turned around a little bit, but it's not, it's still the same thing. Okay? The idea, so your goal is to have the variable on one side, the variable alone on one side, and then all numbers on the other. Okay? So here we can see that we have a variable y. Okay? And beside that y is this plus 5. Okay? So we are going to do the opposite. The opposite of plus 5 is minus 5. And in order to stay balanced, we want to do that to both sides. Okay? And when you do that, you get negative 16 is equal to y. Okay? So now that we have that one, okay, we have these as examples. I want you to take a minute and try to solve this one on your own. So the opposite of negative 4.1 is positive 4.1. Which now gives us x is equal to 4.1. Awesome. With fractions, y'all, it's no different. Don't let the fractions scare you, okay? We are going to add 2/5 to both sides. All right? But something we need to keep in mind is that 2/5 is the same as 4/10. Because remember, we need like denominators so that we can add. So by adding the opposite over here, it removes it. And we have x is equal to 7/10. Okay? And now let's move on to our next example. Remember that our first step is to combine like terms on each side. And if you notice, on the left side, we have these two z terms, and on the right side, we have these two constant terms. So we're going to combine on the left side. 3z minus 2z is just 1z. We have plus 2. And then 3 plus 8 is 11. And now we're ready to go on to the next step of adding the opposite of our b value to both sides. Well, in this case, our b value is positive 2. So we're going to add negative 2, or another way to think about that, just subtract 2 from both sides. That zeroes this out on the left and gives us z is equal to 9. All right, now let's get into ax equals c. So we start out like always. We combine like terms, okay? Then we want to multiply both sides by the reciprocal of the coefficient, or divide by the coefficient. And then check your answer, okay? Now, I've thrown out a pretty big word there, reciprocal. So what does reciprocal mean? Okay, so if we have some number x, okay, the reciprocal of x is 1 over x. Okay? So when we're looking at our first example right here, we have 5x equals 20. Okay? We can multiply both sides by 1/5 or divide by 5. Either way, it works. Whichever technique works for you, go for it. Okay? So I'm actually going to use the technique of dividing both sides by 5. Okay? And that's going to leave us with x is equal to 4. And in order to check this, we can substitute 4 for x. We get 5 times 4 is equal to 20. And that is a true statement. Okay, let's look at our next example. So in the next example, what is going to be our first step? So yes, we want to combine our like terms on either side. Okay, so we get 1.3x is equal to 9.1. Okay. Now, because we're dealing with decimals, I don't think multiplying by the reciprocal is going to be the best option here. So I would go right into dividing both sides by the 1.3. Okay. And that gets rid of it over here and gives us that x is equal to 7. Okay. Looking at this next one, what do you think x is? What should we do with the x? What is it being multiplied by? So it is being multiplied by -1. Okay, so we have negative x is equal to 4. And we can consider that because it's being multiplied by -1, we're going to divide by -1. And that's going to leave us with x is equal to -4.